Hello everybody, welcome back. And we are going to start on the next section to kind of wrap up Algebra 1 for the school year. I still can't believe that this year's already almost over and we only have a couple more note sections, so let's get moving and grooving. Previously, last week we looked at factoring. Okay, so how to solve quadratic equations using factoring, which we've done that a little bit in the past and you all had plenty of practice within that discipline. So if you have any questions going over that, please let me know, because we're going to be starting on our next method for solving quadratic equations. And that method is going to be using the square root property. So this section, similar to last section in the fact that it ties in a previous chapter to solve quadratic equations. Last section, we looked at factoring, which was kind of tied in with our polynomial and exponents chapters. This section, when we're focusing on the square root property, this ties in our previous chapter of radicals. So let's see how that's going to be applied in solving for quadratic equations. A little bit of review. What is the standard form of a quadratic equation? Well, that's going to be x squared plus bx plus c, or ax squared plus bx plus c. All right, let's look at what the square root property is. The square root property ties into the fact that if I had x squared equal to 25, in order to isolate that x value, in order to solve for x, I would take the square root of both sides of the equation and leading me to find that x is equal to 5. This property you'll use a lot actually in geometry, because we use it within a theorem called Pythagorean theorem to solve for triangle sides. So you'll have experience using this property next year, but we're just going to basically be using that for equations. So a little bit of refresher, what is the square root property? The square root property says that if I have x squared by itself on one side, in order to solve for x, I can take the square root of both sides and I would have x by itself. Because essentially, x squared and the square root of x, they're complements. One is one forward method, one is one backwards method. Remember, like by a 3 squared, that equals 9. If I take the square root of 9, that equals 3. It's the same method here. So when you use the square root property, you have to have x squared by itself. So whenever to solve for quadratic equations, your first job is to isolate your x. Get that x squared by itself equal to the rest of your junk. Then you take the square root and solve for x. Okay, you'll use this method when you have equations that look like this. I had ax squared plus c equal to 0. It's most easily used when our formula or equation looks like that. So let's do an example. I have x squared plus 49 equals 0. My first job is to isolate my x, so I'm going to subtract that 49 over to the other side. So I have x squared equal to 49. Now that I have x squared by itself, I can take the square root of both sides, leaving me with x is equal to the square root of 49, which is 7. One thing you want to note is that when you have a positive number, that positive number always has 2 square roots. So what that is referring to is, let's look at this equation backwards for a second. What is 7 squared? Well, 7 times 7 is 49. What is negative 7 squared? Negative 7 times negative 7 is 49. All right, so therefore, when you use this property, your answer is not just simply 7. Your answer is x is equal to plus or minus 7. So that is how we solve for x. And then our final answer would be writing it in our bracket form. So 7, comma, -7. All right? So when you take the square root of a positive number, whatever you solve for that x value, it will be positive x and negative x. All right, let's look at another example. Now, example 1, solve the following quadratic equation by square roots. My first task is to isolate that x squared value. So plus 16 plus 16. I have x squared is equal to 16. I'm going to take the square root of both sides, giving me x is equal to 4. Is it just 4? No, because my square root was positive. So it's plus or minus 4. So my final answer will be 4, comma, -4. All right, let's look at another problem. Example number 2, solve the following quadratic equations by square roots. All right, my first job is to isolate that x value. So I'm going to add 45, which gives me 5x squared is equal to 45. I got to get that x squared value by itself, so I'm going to divide by 5, giving me x squared is equal to 9. Now I can use the square root property and take the square root of both sides, giving me x is equal to positive 3 and -3. So 3, comma, -3. All right. Let's look at another problem. Solve the following quadratic equations by square roots. My first task is to isolate that x value and take the square root. So I'm going to subtract 10, give me 25x squared equal to 36. Gotta get that x squared by itself, so I'm going to divide by 25, divide by 25. Does 36 divided by 25 come out to a nice, neat number? No, it doesn't. Okay, you can make it into a decimal number, but stick with me for a second. We don't want decimal numbers. We want a simplified radical. So I'm going to leave this as 36 over 25. To get that x by itself, I'm going to use the square root property and take the square root of both sides. And I'm going to simplify that radical. Remember when we rationalize the denominator with dividing radicals, you're going to be using those practices here. So when I take the square root of x squared, it leaves me with x. Remember, when I have a radical over a fraction, I can divide that radical up into my numerator and denominator. So I'd have square root of 36 over the square root of 25. I'm going to simplify that a step further. Give me x is equal to square root of 36 is 6. Square root of 25 is 5. My last thing is, was my radical positive? It was. So I'm going to have plus minus. So my final answer is 6/5, comma, -6/5. All right. Last example. Solve the quadratic equation by the square root. Write all answers in the simplest radical form. All right, here we go. First task, get x squared by itself. So plus 16 plus 16. I have x squared equal to, what's 59 plus 16? Is that 75? All right, I need to take the square root of both values. So the square root of x squared gives me x equal to, does square root of 75 simplify down to anything? No, it doesn't. So, or not that it doesn't simplify down to it, it's not a perfect square. Am I done here? No. All right, we still have to simplify that radical. So I'm going to break up and factor out that radical into two square roots. So let me think of what are my factors of 75 that are perfect squares. I have 1 is 75, 5 and, oh goodness, can I do that off the top of my head? 75 divided by 5 is 15. Oh, 25 and 3. All right, 25 is a perfect square. So it looks like that's how we're going to divide it up. So I'm going to divide it up in the square root of 25 and the square root of 3. All right. Now it's time to simplify. So x is equal to, I'm going to take the square root of 25. When I take the square root of 25, what does that answer equal? Positive and minus 5. And my square root 3 stays the same. So my final answer is 5 square root 3, comma, negative 5 square root 3. So really what the square root property does is it pulls all of those radical skills we used in the previous chapter and applies it to solving quadratic equations. You'll notice that trend throughout the quadratic equation chapter. We're not seeing a lot of new content. We're just applying what we've learned over this whole year. That's all I have for you today. If you guys have any questions, please let me know.